Today we're working on review concepts from the Module 6 test. This is Math 1 with Mrs. Sloyan. These are the things you'll need to know for your test tomorrow. One of the things you'll need to know is how to multiply binomials. We've gone over this in class, how there are two strategies that we've learned in multiplying binomials. One strategy is to split and repeat. You can see in this model, I used x plus 4 times x plus 2 as my sample problem. In my split and repeat strategy, my first effort, I used x plus 4 as my split and x plus 2 as my repeat. So I had x times x plus 2 plus 4 times x plus 2. You can also do the reverse. You will get the same answer. Here's the reverse of that. X times x plus 4 plus 2 times x plus 4. You will get the same answer. The next step will be to distribute. So in my first strategy, split and repeat, using x plus 4 as my split and x plus 2 as my repeat, I distribute here. X times x is x squared, x times 2 is 2x, plus 4 times x is 4x, plus 4 times 2 is 8. I have like terms, 2x and 4x. I need to combine them by adding. My final answer is x squared plus 6x plus 8. My other order could be using my x plus 4 as my repeat and x plus 2 as my split. In this, I would do x times x plus 4 plus 2 times x plus 4. X times x is x squared. X times 4 is 4x, plus 2 times x is 2x, plus 2 times 4 is 8. Again, I combine my like terms, and my final quadratic expression is x squared plus 6x plus 8. The other strategy I could use is the box method. In the box method, I've written out in letters what it might be. Here would be a plus b, here would be a plus c. I would have a times a is a squared, a times b is ab, a times c is ac, and b times c, or c times b, is cb. I'm going to use the box method using x plus 4 times x plus 2. I can put x plus 2 up here or on the side. In this first model, I have x plus 2 in this top area. I drew my big box with 4 boxes within. I go across and meet, and I have x times x is x squared, x times 2 is 2x. Then I come down here, 4 times x is 4x, and 4 times 2 is 8. I circled my like terms that I'm going to combine to give me my 6x. This would be the reverse. This would be with x plus 4 up top and my x plus 2 on the side. I get x times x is x squared, x times 4 is 4x, 2 times x is 2x, and 2 times 4 is 8. Again, I've circled my like terms that I'm going to combine, and the same quadratic expression I wind up with is x squared plus 6x plus 8. That is multiplying binomials. Then I check my work. Did I multiply correctly? Did I remember that x times x is x squared? Did I combine my like terms? Remember, x plus x is 2x. If I have an x squared in my expression, I know it's quadratic. Another concept you will need to know for the Module 6 test is what type of function an expression is based on the equation or the table given. In my linear expressions, I'm going to have my y equals mx plus b format with a constant rate of change at the end. My b is my constant difference. When I plug in my x's and y's for my table, I have 1 and 5, 2 and 10, 3 and 15, 4 and 20. My rate of change, or my difference, is plus 5 every time. Okay? So now my 5 is going to be my rate of change. 5 over 1 is my slope. This is my y-intercept. My slope is my constant difference. This is my rate of change, is 5 over 1, my change in y over my change in x. My f of x, which is the same as y, is going to be mx plus b. My points will form a line when I graph them. X, or x to the first, is the highest power term that I have in a linear equation. In number 2, the second type of function we're going to look at is quadratic. In quadratic expressions, my constant rate of change will be in the second difference, not the first difference. So if I'm looking at an equation trying to figure out whether it is quadratic or linear, I'm going to look at my highest powered term. In this expression, 1x squared plus 6x plus 8, my x squared term is my highest powered term. The power term of 6x is only 1. My highest powered term is x squared. That means I have a quadratic expression. A quadratic expression in a standard form is going to be ax squared plus bx plus c. In my table, my xy table, I have 1 and 0, 2 and 1, 3 and 4, and 4 and 9. As I look down my y's, I am looking for my rate of change. My rate of change in my first difference, which is here, is 1, 3, and 5, which is not a constant rate of change. I need to find where my constant rate of change is. So I create another set of differences, which is my second difference, and that is 2. My constant rate of change is in my second difference. This means it is a quadratic expression. If I'm looking at a graph and asked whether it is quadratic, I will know it's quadratic because it makes a parabola. The third type of function we've learned about, but to a lesser extent, has been the exponential function. In our exponential function, our x value is going to be in our exponent value. So as x changes, that is the number of times a will be multiplied by itself. For example, if x were 2, I would have a squared. So if x equals 2, I would have a squared, which is equal to a times a. If x were equal to 3, I would have a to the third, or a cubed, which would give me a times a times a. If x were equal to 4, I would have a to the fourth, which would give me a times a times a times a. This function will increase faster than a quadratic function. When I'm looking at a graph, I will know it's an exponential function because the points will create a hyperbola. It is an elbow shape on the graph. We are looking at comparing our quadratic and our exponential functions in some of our situations, for example, in our tortoise and the hare. To compare an exponential versus a quadratic growth, I've given you an example here. This would be an example of quadratic growth, where y would equal 2x squared. We have our quadratic term here, which is x squared multiplied by 2. My xy values would be 1 and 2, 2 and 8, 3 and 18, 4 and 32, 5 and 50. My change is going from 2 to 50, from 2 to 50, 2 to 50, as I go 1 through 5. Now let's take a look at my exponential change. If I had the expression y equals 2 to the x, and this is what is changing, x, 2x, 2 to the first power is 2, 2 squared is 4, 3